Good afternoon, everybody. Welcome to my presentation on the La Palma eruption. And the La Palma eruption 2 years ago, it was quite a spectacular event and quite unparalleled in the recent history of the Canary Islands. So I'd like to give you a summary of the events and also have a few moments of contemplation about what went wrong and what went well and what can be improved. So I'm gonna start with a few words about the Canary Islands as a general setting. We talked about this in my first presentation, but just a little recap. So the archipelago, the Canary Archipelago, is a volcanic island chain, and it's got 7 major islands, and La Palma and El Hierro are the 2 youngest ones. They sit in the western part of the island chain, and if you subscribe to the plume model, the model where we have a type of Bunsen burner in the Earth mantle over which a plate is riding at a slow rate of about 2 centimeters a year, then the active part of this hotspot, this Bunsen burner feature, is actually right under the islands of La Palma and El Hierro. So this would look a little bit like this. Let's see, I should be able to get that going again. No. Oh, there's the cursor. Okay. So the idea is that we have that stationary mantle anomaly, and the plate is moving ever so gently with about 2 centimeters a year. That's about the speed with which your fingernail is growing, actually. And then we have islands forming on one end, and the plate moves them away while it is moving towards the African continent. So, having seen this, then we can actually get an idea about the different stages of the island of La Palma, and we have the oldest stage in the upper part, in the northern part. There's an old shield, the Taburiente shield as it's called, and we have this younger ridge, the Cumbre Vieja. Cumbre Vieja literally means the old ridge, but it's actually the younger ridge. This is a forestry term, so that has led to some confusion amongst geologists, so it's not about the rocks, really. And the Taburiente northern shield is extinct. It's an older volcano, and the Cumbre Vieja, the southern part, is the active volcanic area. The historical eruptions in the Canary Islands, here's a little table where we list them all. They have been heavily biased towards the western part of the archipelago because of the plume model, the mantle plume model, and most of the eruptions have actually occurred in this small region, the Cumbre Vieja ridge. And here on the table you can see Tenerife and La Palma had most of the historical eruptions, with La Palma leading the ranking by quite some distance. So half of all the historical eruptions in the archipelago took place on this segment of ridge. Not even on La Palma as a whole, but just on this segment. So this makes this the volcanically most active region in the Canaries, and here's a few historical impressions. There's a oil painting from 1677 showing the 1677 eruption, then the black and white photos from the 1949 eruption, and the 2 color images there are from the 1971 eruption. And all of these eruptions are centered they're centered on the ridge crest here, or slightly towards the left and right of the ridge. Now, when the 2021 eruption started, all the volcanologists in Europe got really excited. So I was hopping on the next plane, of course. And here you see my plane ride with Swiss Air towards Tenerife, because all the airplanes to La Palma itself were cancelled. So you had to go to the neighboring island and then go over with a ferry. And here in that area you can just about see there's the volcanic eruption in the distance. And of course, when you go on the ferry, then they had all these warnings. So there is currently a volcano alert, and there it says, do not go anywhere near the volcano. which was, of course, exactly the opposite of what I had in mind. So I was getting ready to geared up towards the volcano, but let's have a few words. So scientists already knew since 2017 that something was not right with the island of La Palma. There was movements underground, and there was seismic activity. And then 11th of September, a seismic swarm at a depth of about 8 to 13 kilometers occurred, and during the following days, earthquake intensities were increasing up to M3.4. That's not too severe. Tectonic earthquakes can be a lot stronger, but for a volcano, this is significant. This throws cups off the shelves, if you will, and this seismic activity was actually rising upwards. So the ground was also deforming at that point, and then 17th, 18th of September, there was a decrease in seismicity. And this is something that we'll find very frequently at volcanoes. There's a rumbling episode, and then it goes calm for a day or two. This is really puzzling, and of course, it would be entirely wrong to assume that it's over. For some reason, the volcano just gets ready for the real event, and indeed, 2 days later, the eruption kicked in the evening of the 19th of September. And it was accompanied by some earthquakes, 4.2, and in the afternoon, the eruption began, and it was immediately sending a gas and ash plume up to 3 kilometers height. So, and it was followed by ejection of lava on a crack of 500-meter length. So here's a little bit of background. This is the deformation we were able to see with the radar, and this allowed us to actually predict where the eruption would approximately occur. And then there was 2 levels of seismic activity. On the right-hand diagram, you see one level at about 30 kilometers depth and the other one at about 10 kilometers depth. And our interpretation was that there was 2 magma reservoirs that were supplying the eruption. And by now we actually have confirmed this with chemistry as well. There was 2 types of magma involved, but I'll spare you the chemistry. Let's look at what happened at the surface. So the eruption kicked off September 19th, and it was actually going really strong to start with, and it was sending out a lot of ash and lava. The lava was traveling with quite some speed, and rivers of lava formed very rapidly. And the unfortunate thing was, it was in a very densely populated area where the eruption occurred. So the volcano itself grew actually a little bit out of the town of El Paso, so not directly in town, but several settlements were downhill from the volcano. This is a Google Earth image on the left where you see, let's see, you see this White House here, there where the arrow is, and this is exactly this White House here. And within 3 months, this volcano grew. So here's a few more images. This is the volcano in January 2022, after the eruption had effectively ceased. And there is a newspaper clipping, Dia 1, Day 1, and Dia 87. So you can see within 3 months this volcano built up, and that calculates to a growth rate of 3.5 meters per day, which is quite spectacular. So the devastation was enormous. 1,200 hectares of farmland and private properties were affected. And here you see some of the houses that were engulfed by lava. And I'll show you a lot more of those images. So close to the volcano, the lava was flowing quite rapidly, and it was forming, it was making rivers of lava that was progressing downhill, and further down it was then spreading out. The topography was quite wide, and therefore the lava developed a delta, as we call it, a lava delta. And here you can see this. So I'll bring that back. Once the lava was reaching the plateau further downhill, it spread out very rapidly, and this was very unfortunate for the population there. So here's a few more impressions of lava coming down, and while it was very runny close to the volcano, it got more blocky further down. This is what we called the other day an AA type lava, and this doesn't travel so fast, but it is almost unstoppable. It has a different way of propagation, and our lava is really not something you can hold off. It will just come and come as long as there's new lava pushing from behind. This is literally unstoppable. So we had then a bunch of measurements right early on. The maximum temperature estimated or actually measured was 1140 degrees C, and 45 million cubic meters of pyroclastic, that means ash and particles were thrown out. The total emitted lava volume was 188 million cubic kilometers, and as I said, it covered about 12 square kilometers of very valuable farmland. Maximum accumulation thickness of the lava was over 70 meters. Can you imagine a pile of 70 meters of lava? And the fastest velocities were more than 30 kilometers an hour. So this is a very fast moped speed. And the maximum magnitude of the earthquakes was above 4. Towards the very end, actually, there was one earthquake above 5 on the Richter scale. So here's a few impressions of a lava. This was my first encounter with what my girls at home would call Jakar, the lava monster. And here the lava was cutting off a road, and we were, well, just on that road. And then, let's see, I should have a video here from that road. Here we are. Let's see that I get this going. So you see, it's a huge wall of lava, and although it moves not very fast, you can imagine that anything in its way is doomed. So, and this is a little closer up. The real dangerous thing here is actually the electricity poles, because they were still live. It smells, good question. A lot of people say volcanoes smell of rotten eggs. It's actually not at all correct. Rotten egg smell is when you have a lot of water mixing with the sulfur, then you get H2S. The real smell is a sting of sulfur. It stings really in your lungs, and this is why the gentlemen, including myself there, had gas masks on that filters the acid fumes. Otherwise, you actually get burns in your lungs from the sulfur gas. So this is the volcano up there in the hillside, and this is down at the village of La Laguna, and this is October 21. And I'm going to show you a picture now from the same site, from the very same hill, and this is December 21. So I'll bring you backwards and forwards. Here you see that there was a few banana plantations left, and here they're all completely covered under tens of meters of lava. And eventually it cooled down. You can actually go on top of it, which I did, of course. So this is now from the very top of the lava, standing on several tens of meters of still warm lava. So you can feel a nice kind of warm glow from the rocks coming up. And there we can look towards the north. So the lava field was monitored by satellites, and here we have the Copernicus, the European satellite system, that allowed us to detect how the lava field was growing and migrating. The red color was the earliest lava detected, and then towards the end, the lava field spread out and was engulfing several other topographic features. To simplify this, here in red, the very earliest lava of the first few days, and in yellow color, the lava field at its maximum extent. So it looked like this during the eruption, and the older eruptions are given here in this yellow color, and they were all happening in much steeper, less populated areas, while the 21 eruption was in a much shallower area that was very densely populated, and this was part of the issue here. The lava spread out more widely. So here's the same thing, but just with the topography and the features marked, and you see the large lava field that has affected the area and wiping out several villages like the Todoke village and part of La Laguna town. So here is a map in the lower right, and this is the thickness map, lava thickness. And the yellow color is maximum thickness, and the red is less thick. So in the center of the lava field, we have several tens of meters, 70 meters in fact, and this will take tens of years to cool down completely. So this will be hot for quite some time. So when we were out there, we sampled almost every day, and eventually there was a lot of media interest, so the BBC sent some camera people to join us out there sampling, and we tried to sample as quickly as possible after the eruption. So this lava there was only a day old. It was luckily very thin, so it had pretty low temperature at that point, but yeah, so whenever there was a new lobe coming, you go out and you take a sample. And eventually we developed our certain techniques, and in the top right you see my foot, and you get quite comfortable with lava balls at some point, and eventually we even played a little bit of lava soccer. But yeah, you have to be a little careful there. But after about a month or two on the eruption, you kind of get a feel for what you can do and what not. But you'll see we quench these lavas, and then there's a lot of steam coming out. There's a lot of heat capacity in the rocks. And of course, each time you go there, there's a reminder you shouldn't approach the lava. So this is an image. Let's see, I think that's a video. So this is when you put a drop of water on a hot rock. So this is literally hundreds of degrees hot. You see in the little thermometer, the laser thermometer, this is 500 degrees hot. And there you put water on it, so it steams away. And you can start touching it at about 80 to 70 degrees C, but not higher than that, otherwise you really burn your fingers. Which did happen a few times, actually. Not myself, but... So another feature that was quite amazing is witnessing the formation of lava deltas in the ocean. So in several places the lava was growing the land. It was going beyond the boundary, beyond the coastline. And there was also an older lava delta, the 1949 delta, which was affected by the 21 lava delta. But then several new lava deltas formed as well. There's big debate about what to do with them, but here I showed this image before. There is a tiny one in the north and a larger one that grew quite substantial in the south of the island. And yeah, there is now discussion what to do with them, but I'll come back to that a little later. So here's a little video. And this is how fast the lava was progressing downhill. You can see the dates here. And then it reached this older volcanic cone. It was flowing around there. And eventually, within less than 2 weeks, it reached the ocean and started to make new land. The lava delta looks like this when you send a drone up. And it's quite intriguing, actually, if you look very carefully. Then here you see that up there is a little bit of a red glow in some of the channels, but overall not so much. But as soon as you reach the cliffs, the red glow gets very strong, which means that there is a lot of lava tubes in the lava field. The lava flows actually dominantly underground. So this is one of the cliffs, and this is after the eruption stopped. You can go there in a banana plantation, and there you see the lava on top of the cliff and how it actually made this lava delta underneath the cliff. And here's just another impression for this, and this is now at the bottom of the cliff, where you can see in the little picture on the right-hand side how the lava came over the cliff, and then it was filling up the depression there. So this was, of course, a spectacular thing, and there's a newspaper article, it's a Dutch newspaper article that shows this, and there was a big worry at the time that the lava will actually vaporize the water and will make a lot of poisonous gases. Luckily, for most of the eruption, the wind was actually bringing the gases out onto the ocean and not inland, and therefore it was actually not a problem, although many people anticipated an issue there. So let's talk a little bit about ash and lapilli. Lapilli is little stones, little flakes of rock that the volcano throws out. And this used to be the road LP 212. And my mentor, Juan Carlos, is taking a little walk there. As you can see, there's no road visible anymore. And this is some of the houses very close to the volcano. You just have the chimneys sticking out. And here's a few more impressions of said houses. And yeah, the volcano is still going strong at that point. Some of these houses have, of course, collapsed under the weight of the lapilli and ash cover. So here's a few more impressions. This is a little vineyard shed close to the volcano. And you can just about see on the right-hand side, part of the roof had already collapsed at that point. The eruption plume was several kilometers tall, and the wind has mainly brought it out onto the ocean, but sometimes also to the south. But some of the particles were transported much, much further. They actually reached northern Europe, but also Central and South America. So there was even some alert warnings about air quality in Central America. So the eruption was affecting not just the local environment, it had temporarily at least an effect much wider than that. So let's see. That's how volcanoes look. These and hear them. It's particles falling. So this was, of course, in the evacuation zone, so there was no residents left. 8,000 people were evacuated. You had to have a special permit to go in there, and this is within the evacuation zone as well. You see the soccer field of Las Manchas village. Well, it is now dug out again, I understand, but of course at the time it wasn't useful. The thickness of the ash is quite dramatic. Here is a section through the ash that we sampled, and there you have the entire record. You see different layers building up. And let me talk a little bit about the problem with the ash, and that is ash in the air is not very good for you if you inhale it. And the reason is ash has very tiny little spines, as you can see in some of these images here on the top right, and they mean the ash lodges itself in your respiratory system, and it will never, ever get out again. So you will have this for the rest of your life, and this can be a cause of silicosis. So miners have this problem very frequently, and if you live close to an active volcano and you're not using protection, then you will have fine ash particle in your lungs as well. So this is the key issue, and it is because of these little spines that the material will stay there. It will not come back. So I talked about lava balls in one of the other lectures, and here's a few of those lava balls that came tumbling down the hillside. Strangely enough, there was already images of lava balls in 1677. They were recorded back then, but we didn't take them very seriously until we observed some of these lava balls in La Palma. So let me show you one of them.
Like a cannonball. It's unstoppable if you're in its way.
So, and then when you go closer, it looks like this. It's actually still red hot inside. And of course, being a geologist, we couldn't quite resist. We had to open it up. And let's see, I should be able, where's the cursor here? There's a little video here.
Go.
Whoa. I see now you can break the entire.
So, and this was quite a phenomenon, and I think I mentioned it before, official volcano instructions are, if things like that come towards you, you have to stand where you are and observe them coming towards you. You don't run away. It takes quite some, guts to actually stand there seeing these things coming towards you. But obviously, if you run away, then there's no control. You don't know where these lava balls go. And if you are seeing them coming, at least you can step aside. So let's talk a little bit about the craters now, the craters of the eruption. So here's a beautiful night shot, and of course there's plenty of them out there. So spectacular scenery at night. And this is the vents in action. And again, this should work. This is about 1 kilometer from the eruption site. This was as close as one was allowed, even as a scientist. And you see there was multiple vents, 3 vents going on at the same time. And this is now viewed from below, from the west. And then I approached them a little bit after the eruption ended in January 22 from the east. And then you can actually walk down the ridge towards the craters. And that's how it looked like in the top right. There was a few trees left, but most of them were dead, of course. And this is how the volcano looks from the west. And here's a few more impressions when you approach it from the east side. I have to say, I was a bit worried at that point. And I had a radio with me, and there was somebody on the other end. They were ready to pull me out if there would have been a problem, but I was all alone there at that point, and I was really kind of having a little bit of wobbly knees at that stage. So, and there you can see the blue haze in the background. There was the question about how it smells. The blue is actually sulfur. When the fumes that come out have a blue color, it's very rich in sulfur, and the smell was just so intense, you can barely breathe up there. So, and of course, I didn't come empty-handed. I went back with sulfur samples. So here on the right-hand side, we have a little bit of sulfur, and you can see there were droplets. So they were actually deposited as liquid sulfur, if you will, a sulfur magma. We believe on Venus we have sulfur magma and some of the other planets. So here we have a terrestrial example of liquid sulfur that was deposited. So a few words after having discussed the eruption phenomena, a few words about the damage. The eruption lasted 85 days, some people say 87, so it was amongst the longer eruptions on the island of La Palma. It led to the evacuation of 8,000 people. There is still some families that are evacuated to this day that did not have the opportunity to go back. And more than 2,800 buildings got destroyed, of which 1,300 buildings are homes. Almost 1,000 hectares of plantation farmland was destroyed, and 70 kilometers of vital roads were destroyed, including the north-south connection on the western side of the island, which was an economic blow to the island economy. So there was no direct loss of life. There was one case of a fatality, but this was a very awkward case, and that was a volunteer who volunteered to clean up inside the evacuation zone because they had to clean out some of the drainages, for example, and make sure some of the electricity would still work. So he volunteered, but he actually separated from the volunteer group and went to the house of his daughter to check that everything was okay, and then he must have gotten into a gas trap or so, meaning that in lower depressions we have a lot of CO and CO2, and the person must have not understood the situation and died there. So it was not actually the volcano, it was actually somebody who illegally went into the evacuation zone, and therefore it was a very sad story, but that was the only fatality during the eruption. While there was no direct loss of human life from the volcano itself, the estimated financial losses are on the order of 1,000 million euro. So, and here a few more impressions. This is Montaña Dotoque, an older volcanic cone, and this was before the eruption with all the fields and villages, and then after the eruption, there was just a desert of lava. And I showed this before, October to December. You can see how the area filled up. Scientifically, really fascinating, but of course it comes with a lot of tragedy for the local population. You might have heard about this intriguing phenomenon. It's called a kibuka. Kibuka is an Hawaiian term, and it means a little island of land in between lava flows. And that's what we see here. So this person's house, or well, several houses here, they're entirely surrounded by lava, and they are little islands that were actually unscathed. They were not destroyed. There was a strange case about a bunch of dogs in one of the islands, on one of these kibukas, and several dogs were spotted from a drone that were still there, and the authorities declined all offers for getting them out. So basically the authorities were prepared to let them die. Of course, the risk is that if you walk over lava, there's a huge risk that you break through. So the decision was actually sensible, saying we have to accept these dogs will die, but we cannot risk human life. Strangely enough, a day later, the dogs were gone. There was a big sign on this house, on this kibuka, which said in Spanish, "The A-team was here." It is not clear who it was, but apparently the urban legend is that a bunch of heroic youngsters from the nearby village actually made a nightly attempt to save the dogs, and they succeeded, but it's not a recommended procedure. So, in early December of 2021, the lava also reached the graveyard of Las Manchas, and here you see the lava going over the graveyard, and this was, for many, considered the ultimate victory of the volcano over civilization. Here's a few more impressions of the lava walls and the houses destroyed, and here you see a big lava wall coming towards several of the houses, and the issue was, of course, all the infrastructure would be destroyed, the electricity poles would be cut, the drainage would be cut, all sorts of things happening there. So, and this is a little house, and the house was just in front of the lava flow, and the lava was getting closer and closer, and well, let me see if I get this to work. So this is the feet of the little house there, and it was actually very sad because the owner of the house got to see the footage we recorded, and apparently the owner was very, very shocked about seeing their property destroyed like this, as you can imagine. So, and this is the house after the lava, and of course the lava eventually swallowed it up entirely. So here's another image of lava approaching a house, and you may just about be able to see it. If you look in between the lava and the house, there we have a lot of burning, and there was actually several cars being burned. So here, if you zoom in, there you see the car in between the lava and the house that lit up in flames. And, well, there's a lot of fusible things in cars, believe it or not, from plastic to tires and seats and all that kind of thing. So cars burn extremely well. And here's a few more impressions. Here the lava was reaching a wheelie bin, and the wheelie bin actually is half melted and half survived. Of course, you can't use it anymore. And here's a few images of various cars, and the heat must have been so hot that some of the glass melted, as you see in the top right. The glass from the windows melted down. There was a very intriguing phenomenon which I would really like to study a bit more. So here you see a burned car, and you see that the lava in the wider picture is blocky, but close to the car it's actually pahoihoi again. So the fire from the car must have reheated the lava and made it flow even further. So the burning of the car must have actually contributed to the heat budget in this local environment of a few meters, which I thought was a fascinating phenomenon. It doesn't help the owner of the car, of course, but I find it interesting. So here is lava reaching a banana plantation, and this is of course a serious issue because a lot of plantation land was affected. I mentioned numbers before. The losses were quite incredible, and several of the roads were of course cut, and that includes the north-south transect that was connecting several of the larger settlements. So this is more roads being cut, and this is the village of La Laguna. There you see the lava creeping into the town and affecting the various properties and of course the infrastructure. So this is us actually approaching the lava flow in La Laguna. Let's see. So this is literally a dead end. So, and then as a scientist, of course, you're interested in studying the phenomena. So a lot of work is currently been done on the interaction of building materials with lava in order to improve the construction materials in the future. So here's another road that is cut off, and while the lava is not as thick, of course, you still can't drive over it. But the Spanish have been really, really fast in building new roads. Here's a new road on the right-hand side, which was built in less than 2 months. And actually, I was one of the first people to drive on it. We had a special permit to drive on it before it was actually opened. And it was bizarre to drive on this brand new road next to the lava flow. But one of the issues was that there was isolated areas. Let me show that to you here. There was isolated areas here that were entirely cut off by lava, but they were still intact. And the Spanish Navy was called in to supply these areas. People were allowed to go in if they had property there, so the Spanish Navy was bringing in people on a daily basis to take care of certain things, to rescue some of the pets and farm animals. And this was going on for quite some time. But now there's a new connection road in the lower part, so you can now go there. A few words about ash cover now. So this is an image or a similar one I've shown a little while ago. This is the Las Manchas soccer pitch, and well, it needs a bit of cleaning up, I guess. And here we have some of the houses close to the volcano. The issue is not just the burden of the material everywhere. The issue is also that as soon as it starts to rain, all of this material will go into the drainage system and clog it up. So this is one of the serious problems, and a lot of new water pipes had to be built very, very quickly in order to supply certain areas at the time. And here you can see the layers of ash, how they build up on top of some of the roofs. And this was one of the houses closest to the volcano, and this was October 27th, where we inspected it. And you could really walk onto the roof of the house because it was surrounded by so much little stones, by so many lapilli deposits. So this is from the same place, and this house really had a particularly tough time because not only was it almost entirely covered with ash, on the right-hand side you see actually a vent opened up on December 8th, just towards the end of the eruption. So this person doesn't only have a covered house, it also has a volcanic vent in their garden now. So this is how it looks when you go there with a drone, and what a spectacular place. I mean, I'm still, well, quite amazed by it. So a few more of those bizarre impressions. This is from October 27th on the left. This was in the exclusion zone, and this was a little bar, and the research team I was with, we had lunch there protecting ourselves from the falling ash. And then when we came back December 2nd, the whole thing had collapsed under the weight of the ash that had accumulated by then. And here is Las Manchas. This was one of the bigger halls, an agricultural storage site, and it had a tin roof, and the roof wasn't very stable. It wasn't designed to withstand the ash. So this was then followed after the eruption by what I would call the giant cleanup. What a huge effort it was. And here you see the roads being cleared out. And actually, we can drive into the exclusion zone. Come with me for a second. So you see the amounts of ash that are on either side of the road, and this was a bit like a war zone at the time. Only scientists, fire brigade, and military was allowed in.
That's where they have been dumping all the ash. Wow.
So, and you see the volcano is still
Yeah,
very
that's
strong right there.
the snow piles from clearing the roads.
Yeah.
It does look a little angry today.
It does indeed.
So, and then the cleaning effort was, well, all sorts of things happened. Some of the cars that hadn't been moved in tens of years suddenly got dug out, so good for them. So this was an old-timer from the 70s, which was buried under ash, so it actually got a new life now, I think, because of the eruption. And here's a few more impressions. Eventually, all sorts of equipment was used. Giant diggers to all the small diggers, clearing garden entrances and things like that. And most of the ash has by now been piled up. So here you see a small digger in someone's courtyard and bringing the ash out into bigger containers, these blue containers. And then the blue containers would then be filled. And here the churchyard of Las Manchas. And it was entirely full with ash, but now it's cleaned out pretty well. And then all of this material was then collected here at these artificial mountains. And this is an entirely artificial mountain where ash had been dumped from all the villages. And now there's big discussion what to do with the ash. There is no clear consensus yet. But here you see this is artificial ash deposits, man-made, because all the infrastructure had to be cleared out. Eventually, most of the people were allowed back, and I witnessed this rather intriguing scene. This was also at the village of Las Manchas, and there was this elderly granny in her white and green top, and there was an inspector on the roof, and the granny was giving the inspector a really hard time. She was kind of saying, I want back in my house. And the inspector said, I'm not sure yet. And she said, I want back in my house. And the argument unfolded, and it got quite serious, you see. She was shouting at the inspector. And eventually the house was cleared, and she was allowed back, and she was very happy. And I was happy too, of course. So, but let's talk for a few minutes about what the issue is. And one of the severe issues here is that there is a lot of population growth in the Canary Islands. It's very popular. People sometimes refer to the Canary Islands as the European Hawaii. And La Palma is particularly famous for hosting retired people. Some people also call it Isla Pensionista, so the island of the pensioners. So it's wonderful climate, it's wonderful living conditions, it's beautiful there. So a lot of people actually go there to retire, and also a lot of agriculture is happening there. So when you look at the population densities here in this map here, you see the yellow colors is high population density, and the pink colors is super high population density. Then we have a lot of people living here and here at the either end of the island. And this is, of course, the eruption maps in different colors, the different years. And this red is the 21 eruption. It was happening to affect one of the most densely populated areas of the island. And while on Lanzarote and Teide we have these large national parks which keep people out, on La Palma there's no such thing, and this is a big problem. Here's a few statistical data from the government in Spain, and this is looking at how the island population is growing. La Palma has been growing, has had a growing population for the last 200 years, quite dramatically. The Canary Islands in general, in the lower graph, have a large population growth. But in purple in the upper graph, you see the Cumbre Vieja rift, and for the fact that this is the volcanically most active area in all the Canaries, it has a very high population growth. And the village or the town of Los Llanos which is there in orange, also has a very high population growth. So we have a bit of a social dilemma. We have a beautiful area, beautiful climate, agriculturally very viable, and people want to live there, but there's a risk of volcanic eruptions. How to reconcile that? Well, I don't know entirely, but I think the reality is that we have to enforce that people are insured, because we can save their lives by evacuating them in time. Nobody died in the Canary Islands in hundreds of years from volcanoes, so I think this is a good situation. We can bring the people into safety, but we cannot ensure that the houses will remain intact and their property. So if they insured, the people that were insured in La Palma, they got their money very quickly. The people that were not insured or had illegally expanded the houses, they are still waiting for the money. So this is a huge problem. So actually, insurances were surprisingly good in paying out once the thing happened. So I think the answer is that, like on Hawaii, we have to ensure that people are financially covered in the future. And then you might lose your house, you might lose your farmland, but if you're financially compensated, it's half as bad. So I think this is where we need to go. And this here is a map, a projection of what people would have modeled or what the predictions were. And in color, we see the prediction, and in a black outline, we see the real lava field. So predictions are very good nowadays. So insurances can actually work out pretty much exactly where the problems are. And there's an example from Central America. The USGS has been helping people there in various areas. For Santa Maria volcano, for example, you could even attach dollar values to certain areas now. And this is what insurances need to say how much your insurance premium will be. And once you're insured, it should be okay. So, my final slide here is new opportunities. Well, there's a lot of discussion now going on. What's going to happen with the new land? Some people say, oh, we want to put banana plantations on top. Other people say, we want to put hotels on top. Scientists say, oh, can we make a volcano park, please? And no consensus yet, so let's see. I'm really hoping for a volcano park, and therefore creation of even a geopark with a lot of volcano tourism, but it's not my decision, obviously. Another important aspect is the ash is useful. The ash is useful for agriculture as an agricultural supplement. There's now research going on in Las Palmas about using the ash as a supplement for concrete, so we are able to build with it. And some rather intriguing product I saw the other day, and that was soap from La Palma with volcanic ash inside for exfoliation. So you can do that as well. And the final thing is that, the roads have to be reconstructed. And in a way, it's not all bad, because some of the roads weren't that great, and some of the planning wasn't that great either. So now La Palma authorities have the opportunity to redesign their road network and make it, well, ready for the next century. So I'd like to close here, and I'd like to close with this little video of the closest I've been to the volcano during the eruption.
How many days did this erupt? How many days?
87 days.
How many?
87 days.
87
3 months.
days?
So,
Please can I ask you,
sure.
how much warning, I mean, did they have like a warning that something's about to happen, or how does it work?
This is usually what people call the traffic light system. There is different stages of alert that you have in those situations, and there's a yellow, an orange, and a red stage of alert. So yellow means there is likelihood of an eruption, orange means an eruption will certainly happen, and red is it is erupting.
How can you tell, how do you know this?
This is based on observations. If, for example, the earthquakes are increasing to a certain level, if the groundswell increases to a level, then the authorities, with advice from scientists, would give an alert. And then they have a committee, the PVOLCA committee, the emergency committee for the volcanoes, and they make that decision. And this comes with a certain consequence. Once you're going to orange, you actually have to evacuate. So there's legal consequences and logistical consequences attached to this. There is currently a court case because some people say that the authorities have not evacuated early enough, while other people say, oh, our house is still standing, why were we evacuated at all? So this is always a problem in those cases. But given that the eruptions are not very frequent, there is always a learning curve with these situations, and hopefully they are now even better prepared for the next eruption. Please.
What are the health hazards for exposure to the ash?
This is a severe issue in many parts of the island, particularly in the month after the eruption. The particle density was extremely high, and this is what people call the P10, the particles less than 10 microns, and if you have high exposure, your respiratory system will be affected. So people were often advised to wear masks and keep their windows shut and things like that. So we will have to see how this unfolds in the years to come, whether people will have more respiratory problems in those areas. But yes, this is a concern. Please.
So I would just like to analogize the situation to the frequent climate change, the frequency of hurricanes and forest fires. Insurance companies can no longer underwrite certain states in the United States. Do you think that that could happen with volcanoes if the risk is supposed to be too high?
Yes, I think it could happen. I mean, the good news is for the Cumbre Vieja, the statistics is not that complicated. It says that we have a 50% chance of another eruption in the next 50 years. So if you live there, it's a pretty high risk, but you may also be lucky and the lava flow may just bypass your house. So this is where the thing is. So you have to make a decision if you're a property owner whether you can take that risk or not. And if you can't take it, I would go for an insurance. And the insurance might not be super cheap, but you will get it back in case it happens. Yeah. I'll come to you in a second, but let's do the other side as well, please. Yeah, please. You go ahead.
This rush to the eruption.
Yeah.
What do they hope to learn when they're going over to see this eruption?
The most important thing was to sample the lava early on, because the very earliest lava will quickly be buried, and therefore it will be inaccessible. And indeed, the composition, the chemical composition of the lava for the first 2 weeks was fundamentally different to that later in the eruption. It turned out later on that the initial lava was from this upper magma reservoir, and then later it was fed from a deeper magma reservoir. So knowing where the lava comes from, we can basically look chemically into the depth of the earth. So it was an immediate rush to get this early lava sampled before it's covered. And that's the same for any eruption these days. We call this high-resolution sampling, and we learn a lot about how volcanoes work inside. In the old days, people would have taken one sample for the entire eruption. And that's, of course, a bit insufficient, seeing that there's huge changes during a single eruption. Please.
I think you said, correct me if I'm wrong, that there was more lava flow underground than there was above ground?
There was periods where lower in the lava field where there was a lot of lava flowing, but you couldn't see it at the surface. It's flowing in lava tubes and tunnels.
Lava tubes and tunnels that are formed by the lava?
Yes. What happens is you have a channel of lava, and it starts to form a skin. It's a bit like the skin on hot chocolate. And underneath the skin, there is still liquid. And At some point, the skin starts to be dark. You can't see it from the surface anymore, but the liquid underneath is still flowing. And this can flow for tens of kilometers. And then at the cliffs, suddenly you have it coming out, so you know there's a lot of movement, a lot of dynamics inside the lava flow. Coming back to you, sorry.
Wondering about the time frame for evacuation. If you live in a path of a lava, how much time do you have to get out?
This is a very, very important question because this is one of the crucial issues in volcanology. Imagine you evacuate a village and the village is not destroyed by lava. The villagers will not be happy with you. So you have to get the timing really right, and that's why you have only a very narrow window. And usually it's a window of a few hours to days prior to an eruption. If you're leaving it too early, it's bad. If it's too close, it's too dangerous. In this particular case, you had to wait until the first vents come up so that you can make a prediction where the lava might go, and that meant the very earliest evacuations were very close to the eruption, within a day of the eruption happening. And then, of course, understandably, people were very unhappy with that because they had to rush. Later on, when further areas were affected, the evacuations got more organized. But the initial thing is always tricky. And I live in Sweden. I compare this to the first snow every year. So what happens is that Sweden is very organized in snow because they have snow every year. They know what to do. But the first day of snowfall is always chaos. So because people are always caught somewhere, you are driving somewhere and suddenly the snow falls. The first day of snowfall is always a real mess. And this is the same with these volcanic eruptions. So for the initial day or two, it's chaotic. And unfortunately, unless you know exactly where the lava comes out, you cannot evacuate a lot of people. You might actually make a mistake.
Get there.
Pardon?
How many days you got there? How many days after it started?
Well, I personally, I got there about 10 days after the eruption started, but part of my team was out there within 2 days.
Valentine,
Yeah.
I didn't tell you yesterday, but I'm an actuary. And in Australia, we don't have volcanoes. We have bushfires, we have floods. There are people that have built their houses in flood-prone areas, and they are finding that the premiums are exorbitant. So the problem is that they're being charged 20% of the value of a house, and they go uninsured. So what happens to them when they get flooded?
Yes, very important question. I don't have the clear answer. I'm not in the insurance business, but I know that in Hawaii, what happens now is that the government actually offered a buyout scheme. That the government says, we buy your property at this particular rate, and if you're not selling, you have no right for any more electricity supply, you have no right for any water, you cannot build anything, you will not get building permission. So basically, you can live there, but it has to be almost an off-grid type of life. So it's your choice, but it's not good for you. So I think this is what would have to happen in situations like that.
I'm working with a politician on this one, and it could be that those that aren't insured must compulsory insure or do something.
That's what I think needs to happen on La Palma, compulsory insurance. This is the only way. It's not always popular with the local population, of course, but I cannot see how we can protect the population from financial ruin in any other way. Please. Yes. You had to submit a proposal to the PEVOLCA, the emergency committee, and they would look that you are educated. So I have to have several courses on volcano emergency behavior. I've also been in the fire brigade for a few years, so I have a rough idea of how to handle. And the most important thing is you sign a piece of paper saying that whatever happens to you is your own problem. So, okay. Thank you very much.